1. And this is question 9. An aeroplane flies east from point A for 2 hours at a constant speed of 420 kilometers per hour until it reaches point B. So straight away, I'm going to get 420 kilometers an hour. I'm going to multiply it by 2, and I'm going to turn that into 840 kilometers. So this distance from A to B is 840 kilometers. It then changes direction by heading 20 degrees towards the south at the same speed until it reaches point C. As shown in the diagram below, the correct distance from A to C is 1450, and the angle BAC is 8.57. Find how long it took to fly from B to C. All right, now what we're looking for is the distance. Time equals distance divided by speed. And what we're looking for is the distance of B to C divided by the speed, which we're told stays the same as 420 kilometers an hour. So the goal of the question is really to find out what B to C is. Now, this is a straight angle right here. So that means that this angle here has to be 160, because 160 plus 20 is 180. So we'll start off with the sine rule and see if we can find out what BC is. So BC, which we'll call X, or we'll write down the sine rule first. A over sine A equals B over sine B. Now, it's any side divided by the angle that looks at it. So for me, it's going to be X divided by sine 8.57. And then on the other side, it's going to be 1,450 divided by sine 160. Now I'm going to cross multiply this, and I'm going to get 1450 sine 8.57, all divided by my sine 160. Once I regain control of my mouse, which I just did. Okay. Sine 160. And what we get there is an X value of 631.76. Now, this then I can correct this into 631.76. Okay, 7626 even. Now, here's what we're going to do next. We're going to divide that by 420. And we get 1.5 hours. And if I press this button here, which is a great old button, 1 hour, 30 minutes, and 15 seconds. 1 hour, 30 minutes, which we know is 90 minutes. Okay, once again, just going to check my my marking scheme, and it is 90 minutes or 1 hour, 30 minutes. Now, the average fuel consumption of the plane is 3.8 litres per second, and the fuel capacity of the plane is 100 litres. Show that the plane will be able to complete the journey from A to B to C and directly back to A at the speed of 420 without refueling. Okay, so I think it wants me to add up the, it wants me to get the total time. Yeah, I'll just do the total time here. So I'm going to do the total, I'm going to add up all three sides together and just do it all in one go. It'll save me 631.7626. Okay, so here's what we're going to do. I'm going to get 840. I'm going to add up 631.7626, and then I'm going to add on the 1,450. That gives me my total distance of 292176. All right, so 2921.76 is the complete distance. I'm going to divide that by 420 to find the time, because time equals distance divided by speed, which is this one here. So it just saves me doing all the Just saves me doing all the separate calculations. I divide that by 420, and I'm going to get 6.956 hours. Okay. And I'm already in, I'm going to go 6.9566, okay? So 6.9566, open. Yep, no need to put it in hours and minutes this time, like 6 hours, 57 minutes, 23 seconds. There's no need because it's sort of in decimals already. Now, that's in hours, okay? I need this in seconds. Now, 1 hour is 60 minutes, and each minute contains 60 seconds. So I'm going to have to multiply this by 3,600. So once again, I've sort of rounded off a little bit, so it's going to be 9.9566 multiplied by 3,600. What do I get? 25,043.76. 25,043.76 seconds. Okay. Now, each second takes up 3.8 liters. So I'm going to multiply this by 3.8. And I'll multiply that by 3.8 because each second I'm traveling takes up 3.8 liters, which is 95,166.28, or just 0.3 liters. So, do we have enough? Well, yes, because 100,000 liters is greater than that. And we just say 100, yes, you do, because 100,000 liters is greater than 95,166.3 liters. Happy days. Now, let's move on. B. The voltage and volts of a certain alternating current is given by the function. Phi of t equals, now, at 110 root 2 sine 120 pi t, find the period and range of this function. Now, let's remember what we know about sine waves, okay? Let's start off really basic, okay? Y equals sine x. We're going to give you a grind from the very beginning here, if possible. What I'm going to do is I'm going to start off with y equals sine x. Y equals sine x. And you'll see a standard periodic function that goes one up and one down. And the reason it goes one up and one down is that the number in front of it is 1. So what's going to happen here is that if I replace that with 110 root 2, now 110 root 2, I'll probably need to put it in decimal for the sake of my calculation. 155.56 for argument's sake. So I'm going to go back here. I'm going to change this into 155.56. And you can see what that does is it increases the amplitude to such an extent that it looks like the graph is going straight up. But if I drag this all the way down, like so, you can just simply see that it goes 155 up and 155 down. You can also see that sine starts in the middle. Sine starts at 0, comes up, back down again, and up and around. All right. So now, what we've done there is we've experimented with sine x, and then we finally did 110 root 2 in front of it. Now the next thing is the angle. What happens to the angle when you change it? So I'm going to change it into sine 2x. Now what happens with sine 2x is it basically changes how quickly it happens. So you'll notice that it takes, at the moment, it takes a full revolution takes all the way up, all the way back again, and then all the way back up. It's roughly 6.28 hours for argument's sake, or minutes. Let's reread the question. Seconds, excuse me. It takes 6.28 seconds to complete a full cycle. Now, if I change that to 2x, it completes the cycle in half the time because it goes up, down, and back up again. Now, there is a formula for this, okay? So, whatever letter comes in front of the x value, the period is 2 pi over c. Okay? 2 pi over c. So, in this case, the letter would be 2, which is 2 pi over 2. And we all know that 2 pi over 2 is going to give me pi, which is 3.14, and we can clearly see that the cycle happens after 3.14. Goes up, comes down, goes under, and it ends up back where it starts at 3.14 seconds. Okay, now, so to get the period of the function, we're going to do 2 pi divided by c. Now, the c value isn't 2 in this function. The c value is actually 120 pi. Now, once again, I'm going to see if my GeoGebra will allow me to do 120 pi here. All right. Now, whatever I just did not go down well with the calculator. Okay, so let's try this again. I'm going to go for 120. I'm going to multiply it. Oh, no, don't do that. 120. I'm going to use the star button. I'm going to multiply by 3.14 just as an approximation, and I'm going to multiply that by x. Okay, I'm hoping that this will give me what I'm looking for. Okay, it gave me the exact same thing. So what I'm wondering is, I think it actually made it happen too quickly. The voltage is actually, look what happens when I spread it out. I actually just had to spread it out really long, and there you go. We actually have a sort of like a voltage function going on here, which is pretty interesting. 120 pi. Interesting. Okay. Doesn't look like a sine wave to me, so I'm just going to investigate this a bit further. Sorry, guys. I fixed it there. I forgot to multiply. So when we go all the way back inside again, it does look like a solid green line as we had earlier. But when you stretch it out, you grab one of these things and you stretch it out, it does actually reveal a sine wave. Well, I did a minute ago. There we go. It's finally flattened itself out again. So you can see here there is a sine wave, and it's just happening at an extraordinarily fast rate. Like that's 4,000ths of a second. It's so fast. So we're talking about voltage is changing its direction really, really fast. Okay. So it's 2 pi over c is the period, and that's 2 pi over 120 pi, because the c value in front of the t, if it's 2t, the c value would be 2. If it was 5t, the c value would be 5. But the c value is clearly 120 pi. So you do 2 pi divided by 120 pi. And you can clearly see that it's 1/60th of a second, or 0.167. So 1/60th of a second is the period. And we can see that because it goes up, goes down, goes back again, and see just slightly above 0.016 is your period. So that's what we're expecting, okay? So that was pretty intense. Okay, the range is your top value minus your bottom value. And as you can see on our graph here, your top value is going to be 110 root 2 and then minus 110 root 2. Because 110 root 2 is your 155.56. So here is minus 110 root 2 is your bottom value, and plus 110 root 2 is your top value. Now, next thing, sketch the function from 0 less than or equal to t less than or equal to p, where p is the period. So it wants me to go to 1/60th. Oof. Because p is the period. Indicate the period range of the function on your graph. Oh man, it's giving us a blank graph here. So this is going to be quite a difficult graph for us to do. So what we're going to do is we're going to go, it's the same. So how many blocks do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we're going to go 6 above and 6 below. Would be logical, okay? Now, it's 1/60th of a second. And I'm going to have to spread this out. So we're going to go from 0, that's equal to t, all the way up to 1/60th of a second. Now I have to break that up. I'm going to break it up into maybe 10 bits. So what's 1/60th divided by 10 as an example? 1/60 divided by 10. 1/600. All right, I'm going to do this in 1/600. It's going to be 10. That's going to be 1/600. It's going to be 2/600. 3/600. 4/600. 5/600. 6/600. 7/600. 8/600. 9/600. And finally 10/600. Now, believe it or not, it's going to be pretty much similar to this graph here. See the way I'm drawing this one? All the way up. It's going to look hopefully a bit like this one. So I have to go up as high as 150 now is my other issue, all right? So I'm going to go that you're going to be, how am I going to do this? I need to get above 150. So that's 6. I might just do it as 180. So 180 divided by 6. 6 blocks, 30. So that'd be 60, 120, 180. And that would be minus 60, minus 120, and u in turn will be minus 180. Okay, now we're going to do this in my table function of my calculator. It's the only way I'm going to get these parts done. I'm going to have 10 points. So here's hoping. So we go to menu, formula, 110 root 2. Square root of 2. Now I have to make sure I'm in radian mode. So shift, menu, angle unit, radians. If I didn't do that, I'm goosed. And sine 120 pi. Instead of t, I'm going to use x. Okay. I'm going to start at 0. I'm going to go to an end of 1/60. I'm going to do a step of 1/600 because that'll be 10 equal slots. Then I'm going to start off here. So it's going to be 0 and 91. Okay, so let's start with 0. Next one's going to be 91, which is barely above 90. 0.2 is going to be 148, which is just barely below 150. And 0.3 is barely below 150. Okay. 0.4 is back to 91 again. 0.5 is back to 0. And then it's going to be the negative version of that. 0.6 is minus 91. So just below the 90 mark. Minus 90 mark. Halfway between minus 60 and minus 120. Then the next one's going to be minus 147. So just slightly below the 150 mark. Another one. Another 91. Finally, another that. Now, please remember that this doesn't go like this. It doesn't just flatten out at the top. It actually does a loop at 155. So we have to go above and then come back down again. And this is our sketch. And once again, we don't bottom out at 147. We go under to 155. We come back up again. And there is my sketch. Pretty similar to what I have over here. Okay. Now, use the phi t to find the voltage when t equals 6.67 seconds. It doesn't say use your graph. It says use the formula. And the phi t formula is 110 root 2 sine 120 pi t, if I'm correct. 120 pi t. We're going to replace t with 6.67. So it's going to be 110 root 2 sine 120 pi times 6.67, close bracket, close bracket. We're going to go to my calculator. We're going to do this. So 110 root 2. Now you could do this question, you can do part 3 without doing part 2. So just because you can't do one of them doesn't mean you can't. This is not using a graph question. Okay, so you can clearly do this question without doing anything too special, just inputting a number really. And I got 147.94. And I'll obviously check the marking scheme. And it is 147.95 because I need to round off to the 2 decimal places, volts. Okay. Now, find one value of t where the voltage is 110. Give your answer in fraction form. Oof. Now, I can use my graph to get a rough estimate. So 110 volts, it doesn't say using my graph, and my graph won't be accurate enough. So if that's 90, 110 would be around here-ish. And I'm looking at somewhere between 1 over 600 and 2 over 600. And the other one's going to be somewhere between, I don't know, 4 over 600. Okay? And you could go back to your table function, but realistically, that's not what they're wanting. They're wanting somewhere between 1 over 600 and 2 over 600. Okay, so it's going to be somewhere in this small region here. Okay? Now, here's how we're going to do it. Okay, we're going to use our formula phi t. And our phi t is going to be 110 root 2 sine 120 pi t. And our answer is 110 because it says it's 110 volts. Now, what we're going to do is going to divide both sides by 110 because there's 110 on both sides. We're going to bring this 110 under and divide it. And hell, I'll even bring the root 2 underneath as well. We'll bring the root 2 underneath as well. What the heck? So we're at this stage here. So we actually have 1 over root 2 equals sine 120 pi t. Now I'm going to replace the angle x. Is going to get replaced with 120 pi t. So I'm just going to simply have sine x. You've seen this already a couple of times. Sine x is going to be 1 over root 2. We're going to use AST sig, which we've been using a lot in this exam. Sine is positive, so there's only 2 quadrants where sine is positive, and that is in A and S. You're completely entitled to do these in angles, and then at the very end, actually no, you can't. You have to do them in radians because the system's in radians, so you're going to probably have to use radians. So usually it'd be 180 degrees take away R for the S quadrant, but 180 is actually pi radians, so it's pi minus R for the S region. Okay, and A is just standard for A. Now what we're going to do is we're going to sine inverse 1 over root 2. Shift sine inverse 1 over root 2. We're going to get this angle. It's pi over 4. So x equals pi over 4. Now that's for the first quadrant. For the second quadrant, however, x is pi minus pi over 4, which is 3 pi over 4. Now I'm just going to rub out, I'm running out of space here, so I'm just going to rub out what we did. Remember I said x is 120 pi t. Okay, so what I'm going to say is they only are after one value anyway, but I'm going to give them 2 values. So I'm going to say that 120 pi t is equal to pi over 4 or 3 pi over 4. And what we're going to do is we're going to divide by 120 pi, so we're going to get pi divided by 4 times 120 pi, or 3 pi divided by 4 times 120 pi. And what's going to happen here? Shift pi divided by 4 times 120 pi. And there's your answer, 1 over 480. And the other answer would be 1 over 160. Once again, probably going to check that this is working all right for me. Yes, it did. They're both correct answers, and they're in seconds, okay? Now, the rate of change when t equals 2. Now I'm sort of lucky because I have the GeoGebra software here. So I'm just going to sort of cheat a little bit in this in the way that you guys probably couldn't. I'm probably just going to go all the way over to see what happens at 2 seconds. So I'm just going to keep drifting right until I see what's happening at 2 seconds. Now, you guys obviously couldn't do this in a test, but I'm just trying to explain the concept here more than anything. Just going to keep going right until I see 2 seconds. Anytime today. I want to see if it's on its way up or its way down, whether I'm expecting a positive answer or a negative answer. And as you can see, it's not exactly. I might actually. I should have done this from the start. Actually, should have crammed it together like so, and then just opened it back up again once I got there. So I'm just looking for the 2 mark. Here it is. Here. Okay. Now we can clearly see that at the 2 mark. I'm just going to stretch this back out again. Going to grab the number 2. Stretch it all the way out. You can see at the number 2, it's on its way upwards. That indicates a positive slope. Now, you could have done that in your table function or your calculator, figured out what happens at 2, what happens at 2.0001. You can do that all day long. Okay, so you could have done menu, calculate 110 root 2, and you could have figured out what's the sine 120 pi 20 pi alpha x, and you could have just like, for argument's sake, started at 2, stopped at like 2.10, and just done it like a really minuscule step of like 0.01 or something like that. And you can see that it's on its way, it's negative, and then it's on its way upwards. So it actually went from 0. Oh, sorry, excuse me. X equals 2. Oh, sorry, my graph is slightly off because I rounded it off to 3.14 earlier. So it actually starts at 0 and it's on its way. I think it might be on its way downwards. So actually, believe it or not, because of the way I drew this graph, you actually can't use it. So what my calculator is telling me that it's on its way down and then it goes back up again. So I'm actually expecting a negative slope here, which will be interesting. Okay, so here's what we're going to do. We're going to do 110 root 2 sine. What am I doing myself? 110 pi t. All right, and that's what you're looking for. Now, what happens when you, for argument's sake, change? I'm trying to think of a much easier way of doing this. All right, so this is phi t. Okay, and if I ask you f of x equals 5 sine 2x, what you guys would do is when you differentiate this, you keep the 5, you change sine into cos, you keep the angle, you differentiate the angle to get an extra 2, and 2 times 5 is 10 cos 2x. That's how you do it. So we're going to do the exact same thing here, except it's going to be on a much larger scale. We're going to keep the 110 root 2 in the same way we kept the 5. We're going to change sine into cos, because that's what happens when you differentiate sine. Because rate of change means slope. Slope means first derivative. Then we're going to differentiate the function. If that was 5t, the answer would be 5, but it's 120 pi, so it's actually going to be 120 pi 110 root 2 cos 120 pi, but the t value is 2. And I'm going to have to lob this all into my calculator right now. So my poor calculator is getting an absolute work done on it today. And it's going to be 120 pi 110 root 2, and it's going to be cos 120 pi times 2. Close all your brackets off. And it's actually increasing at 58,646 to the nearest unit, 646 volts. And I'd obviously be inclined to check that on the marking scheme, given the absolute size of it. And once again, nailed it. Nothing wrong with that answer whatsoever. That is the answer for, is it question 9 or question 7? I think it's question 9. Yeah, question 9. And we're talking about, yeah, that answer there. 58,656 volts. Now it is right, so it's volts per second. It's increasing its way. It's actually a positive slope, which is fair enough. So it was negative and it's becoming positive. It's on its way back up. Oh, it's negative and it's on its way back upwards. That makes sense. 2 was negative and it's on its way back upwards again by that point. So it's, yeah, fair enough. Okay, all good. Whew. Right, that is the end of that chapter. That was a long one.